Hi everyone, welcome to my channel. In this series, we are going over Leetcode problems with Java solutions. If you are using a language other than Java, feel free to follow along and attempt the solution in your target language. Today, we'll be going over Leetcode number 1, twosome. This is a great problem if you are just getting started or you need a refresher. So given an array of integers nums and an integer target, they would like us to return the indices of the two numbers that add up to our target number. We can assume that each input would have exactly one solution and we cannot use the same element twice. We can return the answer in any order. So if we look at example number 1, we're given a target number of 9, so we'll have to iterate through the array. The good thing is that there's only one solution. So as soon as we find the two numbers that equal our target, we'll be able to just return that and we can end our algorithm. If we go ahead and look at number 1, they're returning 0 and 1, which is 2 and 7 that equal 9. One way to look at this in a naive approach is that we would iterate over every item, and if we could not find its complement, we would continue to the next index, check that value's complement across the array again, and continue on that way. The issue with this is that we're going over numbers multiple times, and this makes our algorithm run with a time complexity of O of n squared. We can, in this instance, what we can do is look to our data structures to see what data structure we can use to help optimize this problem. So because we're needing to return the index of the complement and not just the complement, we're going to use a hash map, and we're going to store the complement as the key and the index of that complement as the value. And as we iterate over the input array, we'll store what we've seen already. And this is going to bring our algorithm down to O of n because we're only iterating over the array once, and the hash map lookup is O of 1. So in the end, this will bring our algorithm worst case to O of n. So let's go ahead and start coding that out. First, I'm going to create the hash map that is going to store all of the items that we have seen already and their index. And we'll store this as seen, new hash map. Now we're going to go ahead and iterate over the array. It's less than our nums dot length. And what we're going to do in this instance is first, with the index that we have, we're going to check to see if our hash map already has that. So if it contains key, and actually what we want to do is I'm going to pull out the complement. And our complement is going to be equal to our target minus nums I. So if our hash map already contains the complement, what we would do is we're going to go ahead and then just return a new integer array, and we'll say we want our scene dot get. So in this instance, when we're returning the index from the map, because the index is the value, we'll go ahead and get the value and then return our current index. And that's the instance that we've already found the complement. Otherwise, we'll want to add our current item to the map, and we will do that by adding its value as the key and adding the index as the value. And in the instance that we don't find any numbers that add up to our target, we'll go ahead and just return an empty array. We'll go ahead and run that. And we see that our test cases have passed. And again, that is an O of n solution because we are iterating over our array one time, and a hash map has an O of 1 lookup. So this is a more optimized approach as opposed to iterating over our items multiple times. And that is it for TwoSum. If you have any questions or need additional help, feel free to comment below and I will get back to you. Thank you.